All right. Welcome back to another episode of I'm a Software Engineer. What next? Thanks for coming back, Matt. Thanks for joining me.
Thanks for having me, James. It's good to be here.
Yeah, it's good. I think you're wearing a different T-shirt as well this week.
I have replenished
the
T-shirt stocks, and this is a kind of interesting one. This is Vietnamese Frogger.
Is that a game?
So combining obviously Frogger, the video game theme, and my wife went to Vietnam to bring her mum back here to London. Oh, well, to Nottingham now. I've moved. Actually, I think since the last time we did a podcast, I've moved.
You mentioned that.
Back to the UK, and she decided to buy me a T-shirt, and there it is, Frogger, Vietnamese Frogger. If you've ever tried to cross the road in Ho Chi Minh City, it is very much like Frogger.
Right. That makes sense. I like it. Very appropriate. I won't mess about. So today we're joined by a leader who views organizational design as an engineering problem, from building high-frequency trading logic at the Joburg Stock Exchange to scaling one of the UK's biggest fintechs from employee number 3. He's obsessed with how teams code together. He's a former coder for life turned CTO who believes your biggest impact isn't just the lines you write, but the talent you multiply. Please welcome CTO of Zilch, Sean Hederman. Thanks for joining us, Sean.
Thank you very much for having me. Yeah, thanks for having me.
Hey, Sean. Good to have you here.
Sean, do you want to maybe start by giving our audience just a little bit of a journey that where you started from up to now, and then we can sort of maybe jump into some of those boundary conditions that we're really interested to hear about.
Sure, no problem. My background is started a long time ago. So for my sins, my first proper coding job was Visual Basic 3, way back in the dawn of time, and I'd been interested in coding from quite a young age, and I was absolutely determined I wanted to be the best software developer I could possibly be. I think, I always believed very strongly in passion, and I had it in spades. I had a passion for software development. I did it in my spare time. I did it as a hobby. I always had side projects on the go. And I think most of your listeners will appreciate in that kind of situation, your skills grow quite rapidly. Yeah, went through numerous roles, both as a full-time software developer working as part of a team, all the way to working as a developer consultant for a big sort of outsourcing company in South Africa. My original sort of specialization was probably more around document management and workflow and helping helping large organizations automate their systems. And I enjoyed that immensely. But eventually that sort of took me to the Johannesburg Stock Exchange, where, as you said, we suddenly started dealing with these very interesting confluence of factors. You had super low latency requirements, super high volumes, massive security controls. And that's really where I started, I would say, in my mind, becoming a really top tier engineer. And as I entered the Johannesburg Stock Exchange, I was very much focused on, as I said, carry on being the best software developer I could possibly be. And it was while I was there that I was working with this one quite complex system in the stock exchange, their reference data system, which is a bi-temporal system. You had to be able to see what happened on a day as well as what should have happened on a day. A company might tell you 2 weeks after the fact that they changed their name on a specific date. So you had to be able to show both those elements of it. And it created these hugely complex queries that was really, really hard for the team to get absolutely correct, because it's across multiple data sources. Every time you linked to a new table, you had to make sure you did these queries exactly right. And back then, LANQ for C# had recently came out, and I built a library around Link. And it just basically made it all go away. Is you just join the table and it would automatically handle the bi-temporality. You just put in a using statement, say, I'm interested in the business truth as of this date. You'd write your query and it'd spit out the result. And that improved the speed and quality of everything that the developers did in the entire team massively. And that, for me, I think was the real sort of game changer, that sort of boundary condition of, should I be spending my time doing more code for myself and just churning out tasks, or should I rather be looking at how I can help improve and increase the effectiveness of the teams around me?
So once you finish, what happened after you left the Joburg Stock Exchange? What did you look for next? Then was it more of a management or leadership role?
Yeah, I mean, I'd worked quite a lot at the stock exchange. Is when I started transitioning into a management role, and I wound up leading that team. And that was also around the time that DevOps was taking off. And we were quite early in the DevOps cycle at the stock exchange. So my next role was really to go and help a quite a large company in South Africa called Stanlib, which is basically an investment company that focused on ultra high net worth individuals, one of the biggest in South Africa, and really help them transform the way that they did development. And when I joined them, we were doing, I think it was 2 releases a year. And by the time I left a couple of years later, they were doing 144 a year. So it's really around turning that whole way of working around and focusing more on speed, iteration, and all of our nice DevOps principles, right? Fast feedback loops and all that kind of stuff as well. So that was basically, I was running a software engineering team. I was the head of software engineering at Stanlib. And then after that, myself and my wife decided to move to the UK for a whole bunch of reasons, a career being one of them. And I joined a company called Direct Line, which is a large insurance company in the UK. And basically there I was heading up their DevOps function. I had to transform their DevOps function from a sort of build type organization to be more DevOps focused, as well as building out their cloud environment. And when I first joined, that was just very, very early stages. And we worked very closely with a number of partners to build out a fully PCI compliant cloud environment at Direct Line, which is now used extensively across their entire state.
So, and if I'm right in thinking it was after Direct Line Group that you basically joined Zilch as the third employee, is that right?
Second employee, yeah.
Second employee. Sorry, I had that wrong in the intro. No, my apologies. It makes a difference.
Technically, the CEO doesn't count as an employee since he's a founder. Okay. So yes, there was 3 of us in the beginning. It was myself, Phil, who's the CEO, and Rakesh, who's the Chief Operating Officer. And it was three of us at the very beginning. So I literally had to go from everything technology related. You know, my very first meeting was choosing one of our key acquirer partners. Then I had to dash off to the Apple store with Phil's credit card to buy some laptops and set up the email on them. So really doing absolutely everything across the board.
That's a massive change then because Direct Line Group's obviously a big organization. What drove you to want to do that? Because I assume it would have seemed like a bit of a risk at the time.
Yeah, it was. I mean, I think if I look back on my career, a lot of it, and I mentioned, you know, how I'd done document management and automation early on. I'd come into help JSE and work very much on sort of agile and DevOps kind of transformation project. And so I spent a lot of my career helping big organizations become more agile and do things faster. Zilch was interesting from a technical challenge of start from scratch and do it properly the first time around, which has some lessons that are very interesting. But also, I think, as you say, when you're going to take a risk like that, there's a whole bunch of things you got to factor into, right? So number one is, do you believe in the mission? Do you believe that this is something that should be out there in the world? Okay, and for me, I think that ties very much to that passion and purpose. And very much Zilch is focused on improving credit for very underserved and, in many cases, extorted market. And so that mission was very close to my heart in terms of serving underserved people, especially having come from South Africa, where my really great credit record in South Africa just didn't translate to the UK. This is something that actually meant a lot to me and to Phil as well. I mean, he also came from South Africa and he also struggled to get a credit card in the UK. When he first arrived. So something that had personally impacted us. And we knew that this was a problem in the UK. And then the opportunity to work with somebody like Phil, who had known of him and his father in South Africa. I met him a couple of times, but not a huge amount socially. But his father's reputation was quite extensive in South Africa, again, catering to the underserved credit market in South Africa. And Phil's reputation at that point was also quite well known. So the opportunity to work for people like that on a mission that you truly enjoy and given the freedom to build the technology the way you want to from the start, with certain caveats, of course, which is everything's got to be done fast. It was a great opportunity. As you say, it was a risk. But myself and my wife thought about it a lot and we decided it was a risk worth taking.
Yeah, a calculated risk. Because I imagine a lot of people want to do it, but depending on where you are in your life, it may seem like too big of a risk, but it's obviously worked out, I assume, for you.
Yeah, I mean, I think you know, if I was looking at things to consider when taking a jump like that, I think jumping with people who have done it before helps a lot. So obviously I had a lot of experience. Rakesh had a lot of experience. Phil had a lot of experience. We'd each started companies in our own right. Phil much more successfully than mine. But still, we'd all been through that kind of entrepreneurial thing. We kind of knew what we were getting into. These were all operators. So you could look at the people and say, well, I know these people can turn an idea into something real. Okay, they can execute. I think too many startups that people join tend to be very light on the execution and very heavy on, we've got a great idea. And ideas are useless without execution. You've actually got to be able to turn that idea into reality.
Yeah, my dad always used to say he's full of these little aphorisms that it's funny. I didn't pay too much attention to them when I was a kid or in my 20s, but now that I'm in my 50s, they keep coming back to me. But on the idea, but he always used to say to me that ideas were like backsides, and most people have at least one.
Yes, exactly. No, that's 100% accurate, and it's a mistake. I mean, I see so many people make again and again and again. And the other one I would say is seriously, on a startup, you're going to be working crazy hours. You're going to be doing crazy risks. You're going to be at points where you're going, is this all going to end in the next week? That's going to happen in any startup. And you should be doing it for a reason other than, oh, I think this is going to make me rich. Okay, I think there's got to be a mission there. There's got to be something that truly drives you.
Yeah.
Chalking up a bit of number. Yeah.
Oh, no, just because sometimes getting rich is actually a mission for some people, but you want to make sure that all the people that you have on the team with you also share that mission.
Yeah.
Right? And I think the mission alignment is as important as the mission.
And I think if you want to get rich, there's probably easier ways. I mean, I wouldn't recommend it.
Yes.
I would not.
Yeah, you're absolutely right. I say this, I would do a lot of coaching for younger folks, and I say this about startups, that there's a kind of mythology around the startup that you'll get helicopter money or super yacht money out of it, and really, so that doesn't happen very often, and in fact it happens so infrequently that you need to discount the expected return is zero.
Yes.
But the thing you do need to really do is you really have to have a think about where you are and what employee number you are. Right? Like if your employee number has more than two digits in it, even at a big payout, you're actually not really going to do that with that. You're not going to get helicopter money anyway. It's worth considering.
I think making decisions purely on remuneration is always I mean, one of the biggest mistakes I ever made in my career was around a counter offer. Right. I was working for this place that I used to enjoy working for. A new boss came in and changed everything. I really didn't enjoy the way he was changing the organization. I didn't enjoy working with him. I just didn't like any aspect of it at all. And I decided to leave, and I got a great offer, and I handed in my resignation, and they gave me a fantastic counter offer, which really looked great on paper. And 3 months later, I was handing in my resignation again, because, it doesn't solve every other problem. Right. So I'd always be very cautious of people making any kind of decision on, as you say, perceived outcome like that. There's so much risk to it. There's so much work that goes into it. There's so many factors at play that it's really, I wouldn't say it's worthwhile.
I'm gonna now argue the other side of the table, just for the sake of a bit of fun, and be a polemicist, because I also think that we're in a really interesting time. Talking about boundary conditions, we're in a really interesting moment where the contract, like the social contract, the employee-employer social contract, is not just fundamentally changing, but it's kind of breaking down as we speak. And so I see it with younger folks. The idea of going and working for a corporate, if you're someone in your 20s now, you're studying, the idea of going working for a corporate and the contract, like the social contract that's associated with that, the pros and cons of that relationship have really changed. And I see a lot of folks thinking very differently about how they might approach their next 20 years of work, which is a good segue into my normal opening question, which we slipped over. Yeah, but I found a way to segue back to it, James. Yeah. So you made a couple of really interesting points there, Sean. There was a couple of big pivot points for you. How you think about your career. You'd moved countries, and I share your. You probably did it a little bit earlier than me, though. I think I moved to the UK. Fellow Antipodean, moved to the UK 10 years ago. 2015, I moved over. So just on 10 and a half years ago. But it's a big move. Okay, like to sort of pack everything in a suitcase. My wife and I and 2 kids. We had 7 suitcases, and we turned up in London with 7 suitcases and nothing. Didn't have a job, a house. The kids were.
I had 5 pets. I brought 5 pets with me. So yeah.
God, unfortunately, we had to leave our cat with a family friend because we couldn't bring it. But yeah, so I know I have some sympathy for that. So with all that in mind and all that water under the bridge, what I want to do is pose a kind of like a prompted question for you, which is, imagine you're now, I don't know how old you are, it doesn't matter now, but you can pick up a telephone, you've got a special magic phone sitting in front of you, and you can ring your 25-year-old self. What advice might you give to your 25-year-old self, knowing now what you know?
The quick and easy one is stop messing around so much. I was having a lot of fun at 25. I think, I was earning a decent salary. I was doing a job I loved. I was really enjoying myself. But I think the message I would give to myself is you're optimizing for the wrong thing. Okay. You're spending a lot of your time very focused on being right. Okay. Writing great code, understanding everything deeply, being the person that people come to. Okay. That's very useful, but it doesn't scale. Okay.
I like that. Being right doesn't scale. We're going to come back to that.
So what you want to do is you want to create systems that make people right. And for me, engineering and engineering discipline, that's essentially what it is, right? It's a truth-telling organ. It's a truth-telling process. It's a way of stopping yourself from fooling yourself. Okay. You need to build that into the system. It can't just be a single individual we rely on this one person to never be wrong. That just doesn't work. So I probably tell myself is to focus on that. What kind of systems can you build that allow you to move quickly, that allow you to create an environment which help others do great work and still be right?
I was about to say you dug yourself into a massive hole, and I was about to get I was about to get very disagreeable and say that's absolute nonsense. But you saved it. You saved it with the what was to do that again, because that's actually really good. I'm going to use that. The comment about you engineer systems to be right. So being right is not scalable, but engineer systems to be right.
Yeah, you want to create processes and systems that make you right, that find fault. So typical CI/CD, right? It's a process that helps remove defects and variants from our code, right? We have all these things in software engineering that help us make sure that we're right, all the way from testing, all the way to CI/CD, all the way through linters. There's a million different things, and by the way, AI is adding more now as well that help us be right. You can't rely on a single person to be right all the time. It doesn't work. Humans are fallible. And as we can see, AI agents are fallible as well. You have to create these systems around it. And those systems can be cultural, they can be automated, they can be tools, they can be whatever, but the systems have to be there.
Okay, so now that I've laid the groundwork for my trap, right? I'm just kidding. No, I really love this, right? But now I now have the hard question, okay? Because if I ever have a situation where technology is the only problem, I'm loving it. It's fantastic. So where do people fit in that picture?
Well, I think people are fundamental to it, right? People have agency.
Okay.
And fundamentally, any kind of, and I understand how. And I'm sure we'll get into it in a bit more detail. I understand how AI changes the equation in a lot of ways. Okay, but what I still don't see is AI making the truly human decisions, right? Why does this matter? Isn't that good at that? Okay, it can tell me, I'm trying to achieve this goal, and here's 3 different ways to do it, and this one's probably the best one for these reasons. But fundamentally, humans are going to be meaningfully in the loop for a long time to come, in my mind. Now, does that mean that we have to be in every loop? No, we can be in less. We can start delegating the less important loops, right? But fundamentally, at this point in time, there's still somebody telling the agent, even if you're going pure vibe code, which don't strongly recommend for anything that's going into production. Even if you're going pure vibe code, you're telling it what to do. You're giving it that guidance. And sure, you can try and get an agent talking to an agent and try and figure stuff out between themselves, but they'll just get stuck in a completely crazy loop eventually. So you definitely need a human there. The question, as you said, is we don't know how that evolves over the next several years. We just don't know.
Let's come back to the AI stuff, because I think there's some really good questions there. You made another comment before about, you mentioned the multiplier, and actually the idea of being a multiplier is something that I'm paying a lot of attention to. Talk me through that. What do you mean when you say you went from being the best engineer you could be to being a multiplier?
Well, using that library that I told you about as an example, right? So I could only do, as an individual contributor doing tickets. Okay, there's only so much I can do in a day. I can code very quickly. I can use a lot of tools to make myself as effective as possible, but there's only so much I can individually do in any given day. Now, if I'm working in a team of, let's say, the standard 2-pizza team of 8 to 10 people, now, if I can double my output, that's pretty impressive, right? But what if I can increase the output of everyone else by 20%? that's easier to do, number one, okay, and more effective than just doubling my own individual output. So anything you can do that can scale across multiple people, and as I say, that can be process, that can be culture, that can be tooling, it can be a whole bunch of different things, but anything that you can do that can scale across multiple people and help at every single level or at multiple levels, that scales it even further, that has much more of a multiplier effect. And again, that's why I say I like treating organizations almost as optimization problems, as engineering problems. It's an optimization question. It's a performance optimization question. Do you do one piece of your performance of your pipeline for 100% faster, 100% better, or do you optimize the entire pipeline? Okay, and if it's a multi-step pipeline, most performance people tell you optimize the entire pipeline. Don't focus on just one thing because there'll be constraints that stop it scaling as much as you think it will.
Yeah, I'm always reminded of Amdahl's law and how applicable it is. Amdahl's law was something along the lines of you're getting decreasing returns to performance for optimizing any individual component in a complex system. So the more you, so you sort of get this drop off, and it's funny how that applies to just about everything. And I saw this really great chat one day on a performance optimization, a process optimization person, and they were talking about they did this massive study in a really big organization. And they had, these many step processes that they were working on. And they found out that the total time spent doing work across the total time versus time spent waiting for people to do work was roughly 80-20. So 80% of the time, work was sitting in a queue waiting for someone to do the work. And so everyone was focused incorrectly on Joe's doing this job and we've halved the time that it takes Joe to do this job. But actually that was like one person and the total number of people, time taken by all the people in the process was only 20% of the time anyway. So yeah, it's definitely a great point.
And if you look into the reasons for that, you'll probably find there's a queuing theory problem, which is some particular part of that process has a 100% allocated team that then is causing all sorts of latency problems.
Sean, you've obviously moved from an IC and you've had some shifts in, I guess, the way you see engineering, but now you're a CTO, you're in control of, all the technology for a tech company.
Control is a very strong word. Responsible for is probably the correct word.
Sorry, yeah, you're right there. Hopefully you've got some control. Do you still see yourself as an engineer first, or do you see yourself now as a leader, or a CTO? What do you see yourself as?
It's a tough one. I think it's a weird one about CTOs. I think there's a lot of different types of CTOs. And people come to it via multiple paths. Some very good CTOs never really did technology, and yet you have other CTOs who are super, super technical. I think broadly with CTOs, there's two main classes of CTOs. The one would be the more strategy leadership side of CTO, and the other one would be more the main tech person in the organization. And I think certainly so far is I'm managing to combine both, and we'll see how scalable that is. I am stepping more and more away from day-to-day involvement in coding activities, which I find very, very hard, although a little bit of vibe coding, which can be very dangerous if you let a CTO do it, is scratching my itch from time to time. But yeah, I do like to try and stay close to it. And I do think about engineering organizations as an engineering problem, as an architectural problem, as I sort of alluded to. So where, you might be thinking about, this microservice communicates with this microservice. I'm a very big believer in Conway's law and the reverse Conway maneuver. It's how does this team in this organization communicate with that team in this organization? Do we have the appropriate dynamic tension happening between the PMs and the EMs, engineering managers, right? How can I ensure things? How can I change things to drive the right conversations? So a good example that I always talk about is standards and processes and stuff like that. And the way I sort of see standards is this is not you must do things this way. This is if you do things this way, you don't have to talk to anybody. Just go do it. Okay. Whereas if you want to do something different, that's fine. But now we've got to have a conversation about it. That's all. Okay. So really what you're trying to do is say, how do I streamline the stuff that should be easy and simple while ensuring the right conversations happen when they should happen?
Yeah. And do you get the equal type of buzz from doing these making these decisions as you did when you were, say, shipping new features?
It's a different kind of buzz, I'd say.
Yeah.
I think you have to enjoy working with people, which I do, to be able to get the buzz from that side of things. But it's the same sort of sense of satisfaction, right? It's a little bit more removed. It's a little bit, you pull a lever over here and instead of something happening, you've got to wait a couple of sprints for things to happen, and then you see the impacts, and so you've got that sort of delayed gratification piece to it. But I think it's just as gratifying. You go along and say, oh my God, okay, wow, we actually did this stuff. I think the struggle for me is I'm a very future-oriented person. You asked me what I did the last 3 months, I couldn't tell you. Ask me what we're doing in the next month, and I've got a long list of all the stuff we need to get done. I tend to discount the past and focus on the future. And you do have to sometimes take a bit of a step back and go, oh, wow, we've actually delivered a lot. We've actually done a lot, and appreciate how far you've come.
You mentioned Conway's. Oh, sorry. You mentioned Conway's law there and the reverse Conway maneuver, which I haven't heard that before, but I like that as well. For folks playing at home, Conway's law is the idea that the architecture of the software you build tends to reflect the architecture of the organization that built it. So presumably the reverse. Do you want to talk to me about the reverse Conway maneuver?
Yes, the reverse Conway maneuver is to decide what architecture you want and then design the organization to achieve that architecture. So as an example, at Zilch, we wanted to have a card issuer team that was very focused on just cards. And we wanted that to be separate from the acquirer team that's focused on getting debit cards. Now, they're both card related, but we actually separated them out into two separate teams and sort of enforced the separation. And just separating out into two separate teams naturally creates that separation. The teams go build their own services, they don't really integrate with each other. We make sure they don't sit next to each other, things like that, because we don't really want these two teams communicating. They're solving two card-based problems, but two very different card-based problems. And you think carefully about, well, what teams do I want the issuer team to be collaborating with day to day? Well, I want them to be collaborating with the purchase team, which sort of controls our journey through the app for when you're making a purchase. Cool. So then we want to set them next to the purchase team, maybe have the same engineering manager overseeing the two teams. We try and drive closer collaboration. So a big part of it is really when you look at your organizational architecture and you say, okay, well, I want this service communicating to that service. One of the questions you want to ask is, do I want these two teams just communicating over a service and not really talking to each other, or I don't want them in a more collaborative kind of mode? And that drives a lot of the sort of thinking.
Where does that break down, if at all?
Well, it does break down because, you can have the best of intentions, but then you wander into a meeting and you see the two teams that you think should never be talking to each other in the same meeting. And what the hell's going on here? And that's a very human tension, right? You have people who are trying to increase collaboration and increase communication. And that's in principle a great thing to achieve. The problem that you want to solve with the reverse Conway maneuver is too many communication channels. As your team grows, you get more and more communication channels between the teams. So what you're trying to do is essentially say, these two teams, they shouldn't communicate. So you're trying to cut those communication channels and you're trying to reduce them, except where you want them to be. At the same time, you have this sort of cultural push of, we should communicate more and collaborate more. So you've got these two sort of competing forces that you've got to manage.
I think that's a very interesting little insight there, because I don't think I've ever heard anyone talk about a situation where we wanted teams to communicate less. I don't think I've ever heard anyone say that. But you're absolutely right. And if you think about, you made a comment about organization design is another form of architecture, which I want to dive into in a second. But that comment there is actually quite interesting, because if you think about how we design software, what we really try and do is have high cohesion and low coupling between whatever the boundaries may be. We want the smallest interface between them as possible, and then we want whatever's going on inside the box to be as tight and in sync as possible. But you don't very often hear people talk about, hang on, now these two groups shouldn't be talking to each other, which is an interesting little counterintuitive insight, I think. Just talk to me then about how that software architecture thing scales up to organization design. I mean, beyond Conway's law, is there anything else to take from that?
Well, I think a lot, again, it goes back to a lot of software engineering principles, right? And I think they all apply. So a big one for me as well is queuing theory, okay? Queuing theory tells us that any system at 100% utilization has huge latency spikes, okay? So how do you solve that? Well, you've got to make sure that the teams are not fully allocated. Well, how do you do that? Because you have product managers who are trying to put stuff into a backlog. How do you make sure they're not fully allocated? My solution for that is I mandate 20 to 30% technical debt. Okay.
Say again, you mandate technical debt.
I mandate technical debt work. So
right,
the teams
to
have to,
yes. Yeah. Remediate. I thought you meant you want to inject.
Because I was going to say something revolutionary there.
It comes in naturally. It comes in naturally.
I thought the other thing was counterintuitive, but insightful. That was going to be front page headlines. But anyway, sorry, keep going.
Yeah. So by mandating and say, okay, well, you've got to spend 20-30% of your time remediating technical debt, what you're essentially creating is a little bit of slack in the system. If something goes badly wrong and, oh my God, now we need this critical launch because of XYZ, you now have a little bit of slack in the system as per queuing theory that can absorb those kind of shocks at the cost of technical debt, but that's solvable by maybe doing a bit more technical debt the following sprint.
Yeah, I like that.
You've got to factor in all these things. And as I said as well, just standard performance optimization stuff. What happens if my backlog's growing too big here? Well, it means I've got a problem, right? I've either got too many writers or too few consumers. Okay. This is standard engineering stuff and it applies to organizations just as much as it applies to systems.
So let me spin that around. If we could learn some organizational design tips from software architecture, which I think is fair, what do you think we can learn in terms of software architecture from human design and human organizational psychology principles?
I think the number one would be that humans are non-deterministic, stochastic creatures, okay, that are very unreliable. So what you do is you go and say, well, in a perfect world, let's just say I managed to achieve my original goal back in the day of being the best software engineer ever who never makes mistakes, has everything beautifully tested. Would we need a QA department? Would we need CI/CD if we had such perfect creatures? Okay, we wouldn't. We've created this entire infrastructure of engineering practices to solve for a very simple problem, which is humans are not reliable. And that's the fundamental truth of engineering. If you had something perfectly reliable, you wouldn't need half the processes we're doing.
I like that.
I had a joke a little while ago. I'm sure you guys have heard of the chaos monkey.
Yeah.
At Netflix.
Oh, yeah.
And someone said, oh, you're using chaos monkeys. And I waved to the floor of engineers and I said, there are my chaos monkeys. Because it's, by the way, it's a simple reality, right? Humans inject chaos. It doesn't matter. Best of intentions, they inject chaos everywhere. And in many cases, by the way, that chaos is valuable. It's amazing how often it is valuable. You get some weird idea that you'd never even considered in your original architecture that somebody implements and you go, oh my God, that is so clever. That's such an ingenious way around that. So the chaos is something to be cultivated as well as.
Yeah, I think that's right. I think there's that whole chaos monkey architecture inside Netflix is super interesting. But if you have actually, let me go back a step. You and I have more than being Antipodean in common. In the early 2000s, I was employee number 5 at a startup that built a payment switch from scratch. And so you would probably, given your background, you would know ACI. ACI bought the company that we started was called Distra, and Distra was a completely new architecture for payment switching. The old school payment switches from ACI, they were all built on base 24. And they were built on this assumption that the hardware is fault tolerant, so we didn't have to care too much about the software. So the software was pretty crappy, but we relied on the hardware being reliable. And we came to that whole domain with a completely different approach, which was let's assume that the software's going to fail and build infrastructure to make the software reliable. So then you can run reliable software on unreliable hardware. Okay, so you can drop, so it's completely inverted the model. And it's interesting that the idea of chaos monkey, we had something similar. We didn't call it chaos monkey. We certainly weren't as big as Netflix, but the system was designed to have multi-component failure and recover. And it's quite interesting how the architecture of that software changes once you build in an assumption that it's going to fail. You get very, very different architectural outcome. And as I understand it, Distra is still part of ACI's product suite now. It's currently called, even though it was sold in 2008, I think, okay, if I remember correctly, to ACI, they still call it next gen. So it shows you how the timeframes in the switching market are. When something built in 2008, I mean, it's obviously been continued development on it since then. But so it's interesting how that changes the way you think about software.
Yeah. I mean, I think one of the great sort of religious wars fought among engineers is the types versus safe versus duck typing languages. And certainly from my perspective, I've generally come down on the typed language side of things, largely because I just think it results in less unit test. I just have to test less. Look, maybe, I mean, my background's largely financial services and stuff like that, so you don't want to be making lots and lots of mistakes. You're going to test everything, right? So wouldn't you use things that would reduce the amount of tests you had to write via stuff that you can build into the language?
Yeah. Sean, with, I assume you obviously have a lot to do with the hiring of software engineers now, or certainly
less these days, actually. These days. So generally, we have quite a strong leadership team in the engineering space. So they generally do most of the engineering hiring nowadays.
Okay.
I sometimes get brought in for some of the more senior ones, but that's about it.
Has there been, or do you know of if there's been a change in what they look for in engineers, or particularly since AI has become more prominent? Like, is there anything different about how you hire engineers now and what skills you look for?
I think one of the questions we are interested in finding out is how people are using AI. I don't think there's, at this point in time, I don't think there's a right or wrong answer. I know some organizations are mandating the use of AI. I think some organizations are actually firing people who don't use AI. But for me, I don't think there's a right or wrong answer right now. I think the answers are interesting. I do think that the trend is very definitely in the direction of, if you're not using AI, you're probably going to be losing out. I think that's
What are you guys
definitely
looking for, Sean? What do you look for?
passion, primarily passion, right? We want people who love what they do.
And specifically, I get that. I get
Yeah.
that. And I agree. I mean, that's exactly right. What are the tells that you look for when you're talking to someone about their use of AI that you think are interesting?
Right now, for me, it's more understanding their reasons for why they're doing it, okay, and what they're using it for. So I think what worries me a lot with AI and where it is today is using the AI to write everything and I'm not supervising it, right? That for me is a big red flag, right?
Mm-hmm.
So a question of how you're using it and what are you finding value in it
Mm-hmm.
is what interests me. This person might be finding it super valuable for boilerplate, but they write the main code themselves. This
Mm-hmm.
person might be writing some of the main code themselves, but they let the AI fill in stuff around, observability and do checks for security and a few things around that. I don't think there's any firm right or wrong answer. I think, and one of the things that we're working through as an organization is how comfortable we would be allowing AI to write code fully unsupervised. What kind
Mm-hmm.
of code would we want it to do?
Mm-hmm.
One of the things we're looking at a lot is, what about the stuff that we never wind up getting to, but we know we should be doing?
Mm-hmm.
Okay. And one little pet peeve of mine on this is good management APIs. Go wrong and we write something that does X. Cool, brilliant. Okay. What about deleting X? And what about updating X? And what about making this change to X? And what about backdating a change to X? Do we create the APIs for that? And often in an effort to get the MVP out, those are skipped. And so then, the argument becomes, well, we can't let AI write that because it might be making a mistake. It's like, yeah, but guys, you didn't write it at all. By definition, anything the AI writes is better than what you didn't do, right? So if we find things
Maybe. But so you make a really interesting point here. One of the things I'm noticing is there's a shift to more declarative style programming. And so what you can do is, if you've got some tooling or infrastructure that allows you to be declarative about what you want, I'm much more comfortable giving that declarative interface to the AI to build, because I know what's underneath. I know what the declarations end up resulting in under the hood. So, I mean, just as a particular personal example, I use a thing called Ash on Elixir all the time. And Ash is a declarative business logic layer. So you basically, you sort of declare your business logic kind of attributes, some functions and stuff as well. And then what it does is it maps that onto some very, very, very well written code that is generated using some Elixir generation techniques. But the AI, all it needs to know is what to declare. And then I know that those declarations, if they compile, they're going to turn into pretty high quality code underneath, right? So that's an interesting shift. So this move to more declarative programming rather than imperative programming, I think AI gives you a huge lift there.
Yeah. I'd like to look into that, actually. It's an interesting one, because a long time ago, Microsoft and its tooling had this sort of visual designer that you could create, and you create this custom visual designers. And one of the things I tried to do in terms of this multiplier effect was try and create good code generation off these visual designers. So I could go along and say, this is how we solve in this particular organization the impedance mismatch between the database and the ORM. So all I go is design the entities, and it will go and write the tables and do the impedance mismatch and create the APIs, and it'll do all those kind of bits and bobs. And we found that worked great for about 97% of the code, but the declarative fell down on that 3%. It was really, really hard in a world where now you had to try and fix that 3% because it didn't have decent enough round tripping in those days. I think that's a place where AI can actually start becoming more and more valuable, is helping solve those kind of edge case boundary conditions.
Yeah.
So it's interesting. I'm not convinced on any particular route. I think for me, the big question really is the boundary between deterministic and non-deterministic. Okay, are you clear about where that boundary is? And are you scoping that non-determinism in the right way? Am I making sure, I'm sure everybody's had this experience. If I go along and I give a very complex prompt to an agent that then has to operate on a very complex system, it's going to fail. And it's going to fail hard and hilariously. Whereas if I can chunk things up and I can say, no, this is a very focused agent and it's going to do just the specific task and maybe just output a JSON output, even though it's operating on quite a big piece, it will give me much better results. So mixing and matching and finding the right agents collaborating the right way with each other. You're going to say a software engineer does, cool, what about that one thing over there? That 1 of 50. Let's get an agent to help on that. And that one over there, let's get an agent to help on that.
The other thing that I've noticed, I've been using Claude Code extensively for more than, I think when it came out January, February last year, so just on 12 months now.
Opus 4.6 for me was the game changer.
Yeah, well, interestingly, 4.6 is incredible, except I've coined this term called LLM-zimers. So at about 3 p.m. every afternoon when the West Coast comes online, the quality of the inference just drops considerably. And so I make sure that I do all my planning in the morning on UltraThink and get it all done. And so then in the afternoon, the execution, because it's much easier for it to follow high quality instructions. So if you spend the time doing the planning, it's like if you're trying to do planning from about 3 to 5 p.m. UK time, it's not great. But so what I was going to say was one thing I found, which is extraordinarily powerful, is adversarial agentic coding. And so what I mean by that is it's one thing for you to ask Claude to do something. It's another thing entirely if you spend some time doing a plan and then you get it to review itself adversarially. So I've got a thing I call, I've got this Socrates subagent that I wrote, and it fires up Socrates and Plato, and they have a Socratic dialogue over a question I asked them on the code. And the outputs of that and the refinings of that kind of thing are extraordinary. Like it's way better results than you would imagine is sensible, and it's vastly superior to you just sort of talking to Claude, because it gets into this mode where it just wants to please you. It's kind of got an inherent bias towards being pleasing, and so in order to knock it out of that, this sort of adversarial framing is super powerful.
But that's exactly the kind of thing that I'm talking about when I talk about engineering processes, right? You don't just go and do something; you check that it was done correctly. And whether that's via adversarial. The other one I've been using a lot is spec-driven development. We've been playing around with Kiro, which Jeff Barr suggested to me, and that's been really interesting as well. And I think the combination of Opus 4.6 and something like spec-driven development is, again, very, very powerful because, as you say, you're limiting the context. Let's go and decide what we're going to do. Cool, brilliant. Let's write that down. Now we've decided what we're going to do, how we're going to do it, what's our design. Cool, let's write that down. Now let's go and figure out the tasks for that. Cool, brilliant. Now we've all agreed that, we've all reviewed that. Now go and execute all those tasks. And when I started playing around with Kiro, I was absolutely on top of every single step. With 4.6 Opus, I generally don't even bother looking at the tasks now anymore. I'm focused more on the outcomes of the tests and actually just using the damn thing. And my focus is almost entirely on the requirements and design phase.
You do have to be careful with the tests. One thing I've noticed is it does, I don't know what training material it found to come to this bias, but it has this bias in testing for what it calls shape tests, and they're meaningless. They're absolutely pointless. Like testing if a thing is an array, like a accessories an array and stuff like that. So I had to write a whole bunch of
property tests is another one that allows.
They're just useless.
And it loves mocking out. It loves doing end-to-end tests where it mocks out all the bits.
I have to kill mocking.
That's not an end-to-end test.
Yeah. No, it's the other thing. Like it's mocking stuff that is in like the next module alongside something. It's like, no, just use that module. Like, why on earth are you mocking this? So there's a bunch of these things that have taken me a year to learn, and I've got now like a kind of toolkit that I turn up with a bunch of skills, a bunch of subagents and stuff. But you're right about 4.6. 4.6 was so 3.5 or 3.6, whatever it was when that first came out, was a game changer. But 4.6 is, again, it's a big difference. And just to sort of do the sales job on functional programming, it's way better at pure functional code than it is at imperative OO code, because there's no state. I'm getting a bit nerdy now and into the weeds, but there's no state. Sorry, the state is obvious. There's no side effects when you're looking at pure functional code, and so it can reason about a function in a module independently, and it's way more effective. And if you look at its performance, 4.6 Opus 4.6 is light years ahead. It's daylight second of any other model when it's using Elixir. Like Elixir is the best performing language in the coding tests on, the combination of Elixir and Opus. And I think it's not so much Elixir per se, it's that Elixir is pure functional. So immutable data types and pure functions and so on. So it's a good segue into.
Can I divide the room?
Go.
Okay, so I'm going to make a bit of a sarky comment, but the advantage of functional programming is humans couldn't understand it before the AI was writing it, so now there's no difference.
Yeah, sorry. Well, you have divided the room. Functional programming. Like eventually everyone's going to come around. Yeah.
Let me just say, I've really enjoyed it. I've really enjoyed functional programming when I've done it. I really have. I found it, though, that not everybody gets it, and it can be very hard to scale engineering teams around it.
Yeah, I agree. I agree in part, right? So, like, for example, Haskell, and apologies to all the Haskell listeners in the audience, Haskell is a pathology, right? That it kind of takes over people's minds like a mind virus. And I can't understand a line of it, right? And I don't know who can. But something like Elixir or even Lisp, right, is relatively straightforward to understand, right? It is relatively straightforward to understand. Haskell strong typing, and for me, it's pretty hard work. As someone who programs in functional programming on a daily basis, I still find that quite difficult. But something like Elixir, which is like Ruby syntax, right? Everyone can understand Ruby syntax, right? So it's actually pretty neat. But anyway, so that was a bit of a diversion. That'll probably get edited out. Apologies, because I'll probably pissed off all the Haskell people. But anyway,
I pissed off all the functional people.
Yeah. But the one thing I will say is, over the years, you made the comment about programmers finding it hard to get programmers. What I've found over the years is that anyone who's got a sort of modest competence in functional programming, the correlation between that and high quality engineers is pretty high. Right. So people who have been able to kind of get into functional programming, they're often better programmers. And I'm not sure what's cause and effect. I think maybe you're
right. Makes you think in a different way.
Well, maybe you're right. Maybe the cognitive load that's required to get to that sort of first plateau of being competent in functional programming is such that it rules out some other programmers. So maybe that's the selection.
For some of the reason, I always want people to have tried TDD. Doesn't mean I'm mandated. I don't necessarily expect that every single team do it. But I want people to have gone through that experience of thinking first about how things fail rather than how they succeed.
Yeah, I don't understand the arguments. Actually, so for me, this is like a lot of things. There's these extreme views on TDD, neither of which makes sense to me. So the extreme TDD view is that you have to write all these tests first, and you have to see them all fail before you write any code. That to me is bonkers. And equally, you don't need tests at all, this is insane, that is also bonkers. There's a happy middle ground where you use the language you're programming in, you use that as a tool, as a canvas there, which you do work in to build something up. And then you need a way to test that what you've built works. And that's writing tests. Now, is that TDD? I don't know. But is either extreme ledge of this, like the pathological view that everything has to be a test, or the pathological view that no, we don't need tests? I think both of those are bonkers.
Well, developers always love having these religious wars, right? I mean, it's tabs versus spaces is a good example. Back in the day when that actually mattered, it did actually matter because it would screw up your diffs. And, I always take the pragmatic approach. I try and take the pragmatic approach in these kind of things. I don't care which one you choose, just choose one.
I just push it to the compiler, right?
No, nowadays you can. So nowadays that's a lot easier, and the tool's all handled. It doesn't really matter. But back in the day, it was seriously impactful, right? You'd go along and say, oh my God, there's 5,000 changes in this change. Oh yeah, they're all changing tabs to spaces or vice versa. Brilliant.
Yeah, I mean, eventually everyone will come around to the fact that 2 spaces is the right way to go. Another one to edit out. Another one. Please send all your email. Please send all your letters to James or Sean. I'm too busy to take reader comments at the moment.
Sean, before we go too much deeper there, or should I say Matt, before we go too much deeper there, I've got a sort of question about software engineers. So imagining our audience is perhaps engineers that are fresh as an engineer. Like should they be excited or concerned about their career as a software engineer?
Both, I would say. It's transitional period, right? So from the excitement side of things, I think they should see this as an opportunity to get more stuff done, to get a lot closer to the problem domain, okay, while giving up a little bit of a closeness to the solution domain. In a sense, it's quite simple to the step that managers have to take, stepping a bit away from the code. It's all software engineers are going to have to do this to some level or another as time goes on. So there's a huge amount of excitement around it. Like stuff that used to take forever can now be done relatively quickly. But obviously, we just don't know how this is all going to play out. I will say that we've had transitions that they rhyme with this, that we got told we're going to, completely remove the market for software engineers. I remember, when open source and sort of componentization really took off. It's like, oh, well, how is it that nobody can write their own bubble sort algorithm anymore? Why would you use somebody else's bubble sort? Or developers should just be able to do that. Developers are just going to be people plugging these components together. We're not going to need them. Then no code came out and similar kind of arguments. And generally what you find is that as the cost of writing software goes down, and it does go down on aggregate, the cost of it, the amount of software wanting to be written goes up. Things that were not economic to do anymore before now become economic. Software engineering is fundamentally a problem around complexity management. All that's going to happen, to my mind, is we're just changing the complexity game. Maybe nowadays, in the future, instead of worrying about the complexity of individual code and architecture, you're going to be worrying about the complexity of how various agent swarms interact to create the architectures you want. We don't know how it's going to pan out, but I think managing complexity and the tools that we've developed over the years to manage complexity are still going to be valuable.
Do you suggest
sorry. So what you're talking about there is actually a thing called Jevons paradox. The idea that, what's the exact wording of it? When technology improvements increase the efficiency of a resources use, that leads to a rise rather than a fall in the total consumption of the underlying resource. It's interesting because I wonder about this, right? So there's always this idea that this is all new. We've never seen this before. This is going to fundamentally change things. And I wonder actually about AI. I wonder if it is really something as disruptive as the Industrial Revolution or the printing press, or is it just another tool that has efficiency gains, or is it something indeed different again? I don't know. I have a hunch that it's a bit different, but I'm also, as someone who's been around the block a few times, I'm very wary of saying, oh, this is all new and we've never seen anything like this before, because very rarely is that true.
Yes. I think if we just gone from 0 to 100, if we just suddenly one day woken up and we had full artificial general intelligence, that would be a hugely disruptive event. In a way, my sort of thinking is the path that we're going through is essentially a bit of a soft landing. The LLMs are good, but they're not good enough to be AGI. They're not good enough to completely, entirely replace a fully functional human being. As a human meaningfully in the loop, they can multiply people's effectiveness. Just like, by the way, physical automation machines did so with labor. Is that going to change the structure of society? Yes, it is. Okay, but not as completely and irrevocably as going straight to AGI would have. So I think we'll get to AGI eventually. I don't think we're particularly close to it right now, but I think we will get there eventually. In a sense, I actually think this LLM interlude it helps us. It's cushioning the shock. That doesn't change how shocking it will be.
I'd argue we have got artificial general intelligence now. It's just, to coin a phrase, it's just unevenly distributed, right? There's a jagged edge. Okay, so there is and I'm going to choose my words very carefully because I have very specific meanings of what these things mean. What we don't have is super intelligence, and what we don't have is consciousness or sentience outside of humans. And then there's an underlying argument about whether or not humans have consciousness, or not consciousness, but let's just say sense itself or whatever. Like, there's a whole philosophical argument there, which we haven't got time for today. But I'd argue that we've got a bunch of systems now that act generally intelligent. Now, you can argue that they're better or worse than humans in some contexts, but it's clear to me that in some contexts they're better than humans, and in other contexts they're far worse. And I use the word intelligence. I separate it very, very clearly from consciousness or sentience. Intelligence is just simply being able to act in a way that achieves an outcome, using some tools. And so I'd argue that we've got that. And I'd also argue that the rate of progress there on that general intelligence across different domains is increasing rapidly. And this is the big distinction between the Industrial Revolution and what we're having, whatever we call this at the moment. The Industrial Revolution happened over a period of sort of 50, 80 years. Like, it was more than a generation, right? So in terms of...
And it was still very disruptive, right, to society.
100%. Yeah. Indeed. Whereas what we're seeing now is 12 months ago, the idea of agentic coding 14 months ago, the idea of agentic coding didn't really exist. Okay. Today, if you're not doing agentic coding, with all its pros and cons, you're probably not in the right space. Okay, and that's a 12-month period. So I think I don't know. I don't know. I really don't know where I stand. I'm very, very, very reticent to say never anymore. After saying never a few times and being completely wrong, I'm very reticent to say never. So now
You
the
can almost
question is,
guarantee when somebody says something can't happen that it will happen very
yeah,
shortly afterwards. Yeah.
exactly. Yeah. So now I'm much more in the school of when, as opposed to, won't.
Yeah, I think for me the big thing that's really missing a lot from what we're seeing with agents right now is that they're driving agency / intelligence. It's just a machine following it's a very, very complex machine, but it's just a machine following a set of instructions that you've given it. Okay. It doesn't have its own agency and it's not driving towards its own goals.
Yeah. I agree. But where we're let down, where our intuitions, human intuitions, let us down is in higher dimensionality. Humans have the ability to kind of hold in their head a couple of dimensions that we know about from physical space, 3 dimensions, and then maybe fourth in time. And then if you're a particular kind of mathematician and you've done some research, you sort of understand higher dimensionality up to some number, right? But the number is only got 2 digits in it, like less than 2 digits in it, right? Like you might be able to sort of, and if you've been a programmer, you might have an array with sort of n dimensions in it that you can think about, but you don't have any intuitions about what high dimensionality means and what the relationships between things are in high dimensionality. And this is the thing that LLMs have. They've got like not just larger dimensionality, they've got billions of parameters, and correlation and connection in a graph of information with that many parameters. It's just completely impenetrable to human intuition. So there is stuff going on there that not only do we not understand, but we may not be able to understand because we just don't have access to that high dimensionality. And I don't know what the outcome there is. I think we end up maybe with these black box things where we really don't know how they work.
I think that's fine.
I'm curious, you've made some comments about the 10x programmer or the 100x programmer, and I've made some comments about this kind of thing as well. I think based on our research and chats before this call that we're probably in agreement as to the pros and cons of the 10x, the so-called 10x programmer. But I'm just curious, thinking about what AI does as a multiplier to people's ability to code. How do you think the role of the 10x programmer changes in this era?
Well, I think for me, the 10x programmer was always conflating 2 sort of sides of a coin. So the 10x programmer was maybe 2.5, 3 times better than your average programmer in terms of what they output, but they also helped advance the team and helped improve the team to our sort of point. So they add in 20% on every single team member around them. And that's really where you get the 10x. So if you're thinking about a 10x programmer as somebody who just goes and writes code and you ship pizza under the door, I think those days are long gone and they're going to stay long gone because that kind of problem is now even more amenable to agentic down the line. If you think about somebody who is part of a team and operates with that team and makes that team more effective, now the definition of the team may now expand to include a swarm of agents. That role very much still exists, okay? And it's going to become less and less about the individual contributor and more around the contributions to improving the quality of that overall team and process.
Yeah, I wonder if the 10x programmer actually ever really existed in the sense that just someone. So there are people who are better than others at programming. There's no doubt about that. But my experience with most 10x programmers were actually that the net costs of having those kind of people on a team often outweighed any benefits that you might have got across the team. If they're working on their own as solos, then it's a different story. But if you've got a team of 10 people and you've got one person who is a classic Xer, who does the inverted pyramid thing where they sit themselves at the bottom and they have no dependencies and they break things all the time and it's all downstream consequences and no responsibility for them, that kind of person often is worse for the team than not having them. I'd much rather have 9.9s, right, or ones than one 10x in the team.
Yeah, if the 10x is focused purely on their own delivery and are not helping it. We had a very interesting thing, a team I was looking at a while back. And if you had rated this team on their output in terms of story points or issues or whatever metric you wanted to use, one of the developers was just not performing by any sort of objective measure you cared to name. But whenever they weren't around, the overall team output dropped in quality and throughput. They were such a force multiplier to that team that they were worth far more than the individual contributions could possibly be aligned to. Now, that's the kind of 10x program I want to see.
Yeah,
don't get me wrong. I think you should be doing individual contributing stuff as well, so you stay close to what's going on. But I think that's far more effective.
Yeah, I heard someone the other day talk about the best 10x programmer they ever had actually wrote 1/10 of the code of everyone else on the team, and I thought that was That was actually quite smart. They spent all their time coaching and pair programming. And so all the commits, because some management boffin up the chain decided to rate how people were doing based on their commits. And of course, the person everyone knew was the best programmer on the team turned out to have the lowest commit numbers.
Yeah.
And so
this was the case. This was the case that we had. Is I think this person was on average 30-40% less than the other developers on the team.
Yeah.
In terms of their individual commits, but again, as I say, you took them out of the team. They went away on holiday for 2 weeks, and you could just see how things weren't as effective.
Yeah, it shows you how bad a measure code like output is as a metric. I
always joke one of the most effective pieces of code I ever wrote was 4,000 lines of deletion.
Yeah.
So it's sped up the system dramatically.
Yeah. A very early manager I had said to me one day, he goes, this is back in Australia, back in the early 90s, he said, every line of code you write costs us $1. And it was just a made up number, right? But it always stuck with me that having more code actually meant more cost.
Yes.
Not necessarily more revenue.
Yes, absolutely. 100%. And it's something to keep in mind in the agentic world as well, right? Just throwing out code isn't necessarily the best idea.
Well, just a little bit conscious of time. Thank you so much, Sean. I think we could probably get you on again. And, I'm sure there's a time in the future where you can tell us more about the Zilch journey from where it is now to perhaps where it will be in a couple of years' time. But thank you so much for coming on. We'll pop some notes with this podcast so people know where to find you, maybe link to LinkedIn. But yeah, thanks so much for coming on. Really appreciate your time.
Absolute pleasure. Thanks so much for having me. It was a really interesting conversation.
It was great. Really great to talk to you, Sean. I really enjoyed that.